We saw in the previous chapter that a moving body defends its states such as distance and position against the acting forces which force the states of the body to change. Of course, we can also imagine that a moving body defends itself against the force that forces the body to change its speed, even in its speed state. Then this would have to have a persistent force with which it opposes the external force, regardless of whether it is acceleration or braking. The question is how and how great the persistence should be and with what mechanism this should happen. From everyday experience, for example, we know the phenomenon that the faster it rolls, the more difficult it is to bring a car to a standstill. Conversely, the faster a racket flies, for example, the more difficult it is to accelerate it any further. There is apparently a persistence behind this behavior that should somehow have to do with the speed of the body. The faster the body moves, the greater this force should be. Assume that the body has a persistent force F, the strength of which increases with speed. If it is driven by a force, F equals ma, this persistent force grows more and more with the increasing speed, while F remains constant. Then, at some point, there will come a point where the persistent force balances the driving force. After that, the speed of the driven body cannot increase any further and is limited to a maximum. Because the persistent force always compensates for part of the driving force, the speed of an accelerated body cannot be calculated using this normal equation. If this persistence force is a function of variable v, speed, it could look something like the following. Assuming this maximum speed is v asterisk, the resulting inertial acceleration must be equal to the driving force A. But how should the inertial force actually be? For an orbiting body, nature has provided a mechanism, the centrifugal force, with which the body can remain in some of its states. Is it also conceivable that nature uses the same method to defend the speed of a moving body against the external force acting on it? Because this method is only suitable for a circular movement, could it then perhaps also be valid at least for the persistence of the speed on such a circular movement? With this in mind, we would like to assume an acceleration A equal to v superscript 2/r as a persistent acceleration to see what will come out. If a body m is accelerated by an external force F equals ma and circles around a center point with radius r, it opposes this with a persistent force like the following. Then an equation like this can be made. This equation can be solved simply like this. This results in when theta is infinite, that is, when the body has circulated infinitely, the body's speed is limited to its maximum. It is the maximum speed resulting from the driving acceleration A and also corresponds to that from the persistent acceleration A. So a direct hit. And we also know that a body that orbits with the velocity v around that center point with the radius r always brings with it a centrifugal acceleration az, which must also match. That means that this persistent force is unique and equal to the centrifugal force. From equation, asterisk, we can see that if the initial speed v0 is greater than the speed root, ar, the speed of the body is braked and at some point reduced to this speed. This phenomenon is also very strange physically, which will be explained in detail later. So the final velocity of a body accelerated by a, regardless of its initial velocity, is always the same as the following. Therefore, this speed root ar can be referred to as the target speed. The reverse applies. If a body has been accelerated by a force F equals ma to the maximum speed v equal to the root ar, although the body is still being accelerated by the driving force, its speed can no longer increase. That is, the body moving with a velocity v and a radius r has a persistent force like the following, with which it remains in its speed state against the external driving force. That means, if you want to change the speed of this body, you need an external force that is greater than this resistance, regardless of whether it is a question of accelerating or braking. That the speed of a body accelerated by a is limited is a basic physical knowledge that we did not know. We will see how important this new knowledge plays in the whole of physics. Thank you very much for your attention. See you next time.